Our group consists of Nicholas Garneau, Kyle Griffiths, and Shenli Pei, and we are team #Kato. This is our presentation for Heat Transfer Laboratory. The heat pipe works by using natural heat transfer with no outside power or work. When the pipe is placed into the boiling water, the working fluid, acetone in our case, is exposed to this environment and will boil, creating vapor that will rise to the top of the pipe. Once out of the boiling water, the vapor will start to cool and eventually condense back to a liquid state, which then releases latent heat through the pipe and fins as it goes through this phase change. The now liquid state acetone in the pipe will be replaced by newly vaporized acetone that will fill in behind the dropping liquid. These processes happen simultaneously, which create a constant cycle of vaporizing and condensing in the pipe, thus cooling the water.
This is our heat pipe design. It consists of a half-inch outer diameter copper tube, a copper cap, copper fins, a valve, and working fluids. To construct this heat pipe, first the copper tube was cut to a desired length. Then the copper cap was soldered at one end and the coupling is soldered to the other end so that a valve can be installed later. Acetone was chosen to be this heat pipe's working fluid because it boils at 54 degrees Celsius under 1 atmosphere pressure. This implies that acetone will vaporize at the testing condition, which is around 60 to 80 degrees C. Therefore, no additional pumping system is needed prior testing. However, a vacuum environment will have a better performance. To do such, the heat pipe was put into a hot water reservoir with the valve open. The boiled acetone will push out the air inside the tube to create a vacuum environment. Then the valve was closed to seal the heat pipe. Additionally, the valve acts as a safety feature to prevent high inner pressure that will lead to a potential hazard.
Our design was a total length of 14 3/4 inches. Our evaporator length was 7 inches, insulator length 2 inches, with fin dimensions of 1 inch long, thickness 1/8 inch, and each small fin used was 1/2 of a large fin. The acetone volume was 25 milliliters. To the left, you can see the raw cost of each component of our device along with the total cost used in our device. As you can see, the total cost of our pipe was $13.60. First, in order to see how effective our design was, we first did a control test over 15 minutes with water cooling by means of natural convection. This test yielded a result of a decrease in temperature of 18 degrees Celsius. Next, we modeled our pipe to determine an approximation of how much our pipe would decrease the water temperature. This yielded a result of a temperature decrease of 21 degrees Celsius, which is 3 degrees better than natural convection.